we discussed earlier that spreading can help us in mitigate or reduce the effect of interference, okay, narrowband interference or jamming sometimes. Okay, so if we neglect the effect of the channel and assume it to be perfect, right, and we have this jamming or interfering signal, now it will get demodulated at the receiver, right, and then it will be despread, or it will get spread actually at the receiver, and then it will go through the Marsh filter, hence the integration here, right. So of course this is due to the effect of filtering, the high frequency component, remember this is 1/2 of 1 plus cosine 4 pi ft, right. So this is high frequency component, this will get cancelled out with by the Marsh filter, and we will get this part, right. So actually what we are doing is that we are spreading the narrowband noise and making it wideband noise, and then we are low pass filtering it. So the energy of the interference, firstly it will get spread across all the bandwidth, and then it will be filtered out or cut due to the Marsh filtering or low pass filtering effect. So this is the signal before spreading. Now it is spread, and then the interference is added in the channel, right. So the interference is, as you can see here, has smaller bandwidth when compared to the spread signal. Now at the receiver, when you despread this signal, you get the original signal. I'm meaning this signal, sorry. When you despread this signal, right? This signal, you get the original signal. And when you spread this signal, the interference, you get a wide band signal. Then you filter it out, so effectively you are reducing the energy of the interference signal, right. As for ISI or inter-symbol interference mitigation, now if we include the effect of the channel, we have a multipath component here, right. Now what we do is that we synchronize to the first component, the line of sight component, the high power component, right. The other component, we are not synchronized with it, right. So this is what we get here. So this is the first component, right, after despreading and demodulation here, and this is the second component, and this is the noise component now. Okay, after filtering we get this signal, which is actually the signal coming out of the first multipath component, and this is the signal of the second multipath component. See, this term goes to 0 due to the autocorrelation property. As you remember, the autocorrelation property is like an impulse here. So if they are not within the same small delay, time delay, they'll get cancelled out by the autocorrelation property, because this is the autocorrelation property of the code, right, which is approximately an impulse. Okay, so we get this, right. So graphically, this here we have two spectrums, one for the first component and the second one is for the second component. When you despread them, since they are not synchronized, the other one will not get despread, and you will be reducing its energy.